Okay guys, so on this video I'm going to try to explain freezing point depression. The same principles apply when you're doing boiling point. So if you understand this one, basically it's the same thing for boiling point. And again, I'm apologize. I'm going to rotate the video and okay. So this is the general equation, and I know in your homework you were asked about this. So delta T, the letter delta is a Greek letter that means change. So change in temperature equals I times Kf times M. Okay. Let's talk about what each of the variables represents. I is the number of ions. Okay. That means how many ions are in your solution. Or number of particles. Probably number of particles is more accurate. Okay. So I'm going to talk a little bit about I because a lot of you are still confused on that. So if we have something that is an electrolyte, electrolytes are ionic, and I know last week you guys were talking about this. Let's focus first on electrolytes. So these are ionic. So that means that we have a metal and a non-metal. So I have two examples here: sodium chloride and calcium chloride. So the first step is that you want to split it into ions. Okay. So sodium chloride. Hopefully everyone knows how to do that one. It's just NaCl minus, okay? So if you notice, we have 1 and 2 ions. So that means I is 2, okay? But for calcium chloride, we split it into 2 ions. And when we have to balance the equation, we add this extra 2, right? Because here I have 1 calcium and 2 chlorine atoms. Sorry, I spaced out. So when we have to balance it, we have 2 chlorine ions and 1 calcium ion, right? So 1 plus 2 gives us 3. So the I is 3. So anytime we have ionic compounds, they're going to split into more than 1 ion. So I has to be greater than 1. Now, in the case of non-electrolytes are covalent compounds. So in this example, I have sugar. Hopefully at this point you understand what a covalent compound is. So basically you make them between non-metals. So covalent compounds don't dissociate because they're weak, they're non-electrolytes. So they're going to stay the same even if you put it in solution, right? So that means I equals 1 because it stays as the same species. Okay. So now I talk about the Van Hoff factor. Usually we call the I the Van Hoff factor, but you guys don't care about the name. So let's go back to the equation. So that's I. So now let's talk about Kf. Kf is a constant. It's just a number that it depends on the liquid. So most of the time we're talking about water. So in this case, the constant is going to be negative 1.86 degrees Celsius per m. Don't confuse that m. That m is not moles. It's not molarity. I will not mention the name because we haven't mentioned it in class. Just know that that M, what it represents, it's moles per kilogram. Okay, so that's